So welcome, ladies and gentlemen. My name is Theo Sander from Composites United Switzerland, and I welcome you to the web seminar, Production Ready Tooling Materials with Large Format Additive Manufacturing, presented to you by Gregory Hay, Lunn, and Zack Skelton from Airtech Advanced Material Group, a web seminar from the series CU Member Innovations. Allow me a few points first, like cameras and microphones are switched off and should stay switched off during the web seminar. For any questions and comments, please use the time after the presentation. You can either raise your hands and then you will be unmuted and you can ask your question directly, or you can write them in the chat. I will read them and then you get the question answered. The web seminar is going to be recorded and we will put them on our Composites United YouTube channel afterwards. And now I'd like to hand over to the Airtech team and wish you much pleasure. Thank you.
Good day, everybody. My name is Gregory Hay with Airtech International. Today we're going to talk about production-ready tooling with large format additive manufacturing. We'll start off with some basic introductions to myself and the team. So I'm the Director of Additive Manufacturing for Airtech International's additive manufacturing and materials efforts. So this is everything from very large scale platforms like we're using in-house at the moment, down to other pellet fed and filament fed FDM process type machines. My background is a little diverse, but I'm an industrial design background. I'm coming more from a product perspective in my time, but I've also had about 10 years experience in automotive composites development and design. And I was fortunate enough to be involved with this technology since it was basically invented and early commercialized with Oak Ridge National Laboratory and my previous employer. And so I was fortunate enough to be working on some of the very first machines, large scale polymer composite printing back in 2014, and work with some of the first applications of these resins and their formulations as they became commercialized over the past couple of years. And so now I'm fortunate enough to be here at Airtech, where we're continuing that push to have the best resins and products for various applications, but our specific focus is on tooling applications as a composite focused company in our supply chain and supporting all of our customers globally that use our products.
Hello, my name's Philip Lunn, also with Airtech International. I'm the Global Technical Manager, responsible for global technical activities, developing products and supporting our customers with their applications. I've got over 30 years experience of composite fabrication, originally starting in aerospace with some time in automotive and motorsport before I joined Airtech Advanced Materials Group about 24 years ago, and come to the project of 3D printed tooling with the experience of fabrication of composite tooling using traditional wet layer pre-preg resin infusion type processes to produce composite tooling, and bringing that understanding to the development of 3D printed tooling to develop tooling which is meeting the requirements already expected by the market, but building on that as well and developing and improving what can be achieved with tooling for the composite application.
My name is Zack Skelton. I'm a senior technical support engineer, work with Phil and his group, been largely involved with the resin formulations and the qualification testing that you'll see here soon. But my background has been in composite tooling and composite fabrication, and I've spent the last couple years helping to bring this technology forward so that it is ready for ultimately the production floor.
Thanks, guys. So as you see, we brought a good team for you guys today, and we're going to kind of walk through trying to bring some clarity to the technology readiness of these resins and this process. And so on the back end of this, Zach and Phil will both be available, as well as myself, to talk through any follow-up questions you guys may have in a Q&A session. So we look forward to your questions on the back end of this. So really, additive manufacturing is a new technology for most people, but there's many barriers to production use that people tend to recognize or think are not yet mature. So these are some of the things that we've recognized that are either commonplace or people's perceptions. But there's generally speaking, there's been a lack of mechanical data on the current materials that are available for primarily these FDM or FFF type of applications using filaments or pellets. And maybe not a whole lot of information of these tools or end-use parts being proven in application. Especially at large scale. And just not a large history of these materials being used in these applications. And so it takes some time for, obviously, once the technology is mature, for these applications to meet reality and be used in their intended either production environment or their application. I think in large scale tooling specifically, one of the biggest misunderstandings is that you cannot have a vacuum integral printed tool. I'd say it's something that tends to be very challenging on some small scale FDM or filament type machines due to the bead sizes and the ability to have a continuous surface without machining. And so at large scale, these rules are a little bit different, but as well as having the right materials really matter. And especially the large scale, CTE really matters, right? Because you're talking about parts that may be 1 meter, 2 meters, 12 meters long, right? So CTE matters at that scale in these tooling applications specifically. And understanding how strong these materials really are. We're talking about engineered polymers with often various fiber reinforcements. So a lot of these materials are approaching or equal to metallic competing products. But also we have the ability to now achieve high dimensional accuracy. So in the process we use and many others use for tooling applications, we're printing to near net shape and then machining to high accuracy. So really your accuracy is just a function of machining tolerance, but also your design and polymer tolerance, right? So you have other things to consider here, and CT being one of those in use. And then also understanding, can these tools be used with all the kind of requirements they have in dimensional stability, vacuum integrity, and durability, right? So that they're used in application. Can these tools be used in various environments? So both room temperature all the way up to autoclave pressurized scenarios. These are all the kind of questions that are all frequently asked and talked about with our customers. And so we kind of took this as our goal to go and solve these problems, right? So not only just the materials themselves, but looking at the materials in their application and can we prove out their performance? So, from materials and functional testing perspective, most materials that are on market, the standard was just using injection molding data. And that's not real for these applications, right? The properties you get in X and Z are much different in a printed specimen using FDM or FFF type processes compared to an injection molding compound. The properties in all directions, as well as the CTE, are all impacted by this versus a injection molding type of coupon. So this really helps us, starting with the right data really helps us and our customers that are designing these tools or structures to have the right toolkit, the right data to make good informed decisions on design and how the tool and our part is going to work in their applications. And so without these key metrics of data from printed specimens that are subjected to testing in these various modes, it's very difficult to be able to do a proper analysis and proper design. And so we've made that our mission to be able to go through and do all this work, have the entire list of all the properties for these materials in their applications, in a printed application, and then be able to hand this to our customers of either that we're producing tools for, or that we're providing resin to. And we're fully transparent about this. We do it even with third-party labs to validate this information. So it's fully open to our customers that here's the actual properties. There's no marketing to it. It's here's the data and here's it verified by third parties. And we're doing this with various different applications. So not just our large scale machine. So we happen to have a thermo LFAM that has about a 12-meter long bed by about 2 meters tall and about 3 meters wide build volume. We're machine agnostic in this, right? So any machine that uses FDM processes with a pellet fed type extruder or a filament fed extruder, our materials can be used in on those platforms. And we're working with various different machine manufacturers to, again, do the same level of diligence we've done on testing the materials in printed specimens or printed structures to understand the performance based off different aspect ratios or different extrusion conditions. But we also try to look at design over time, right? So a printed dog bone specimen or test specimen is a very isolated scenario, right? That's your best case scenario. But we also understand as you're producing these complex structures or tools, and you're pushing the limits of layer time, or you have a heated chamber or an unheated chamber, how can you manage your mechanical properties over the course of a print that may be lesser or more complex? And so understanding, again, going back to that raw data, we also have great information that shows us how these materials perform over different times and layers or different designs to help our customers be more successful. Again, that track record's been missing. And so we're going to prove that. Our focus has been specifically on tooling, as Airtech is supporting our broader global composite customers. We are looking at how do we solve these problems for our customers every single day in various applications. So everything as simple as a printed master or basic trim jigs or drilling jigs or sawing fixtures. These are low duty applications comparatively, but require good, tough, durable, and accurate surfaces. So we do that all day, every day with a lot of our customers, even in production type rate tools today. But the biggest scrutiny is to come on the high temperature side of things. And this is where a lot of people seem to be most interested, is high temperature tooling applications, right? So either high temperature out of autoclave or high temperature in autoclave is where there's a lot of cost in the tooling and a lot of time. And so this technology with our high temperature resins has been very attractive to a lot of our customers. So to help kind of debunk if these tools could be used in these processes, Airtech made a large investment into taking this example tool you see on the screen and placing it through a rather rigorous testing regimen to prove that it could be production feasible and capable compared to anything else that's been in the market. And previous to this, the only real information that was out there was maybe a handful of customer data, a couple of labs had done some specimens that maybe had done 10, maybe 20 cycles, and called that good enough, or saw some reasonable data that they thought was going to be good enough. We heard from our customers, they're looking for more information than just that. So we internally invested into cycling a tool to over 250 autoclave cycles. And we use kind of an unconstrained shape here. You see it's a little bit of a U shape with some contour in it. So we can look at any movement that might happen at the far extremities of the shape. But that criteria as we've gone through was, the tool had to meet the same requirements as a production tool might. So it had to be vacuum integral from the first cycle to the last cycle without any sort of repairs or patches or other sealers required. But we're continuing to we've already reached this, this threshold of 250 autoclave cycles with great success. Even pulling laminates along the way and finishing this tool to a high level. So, even in this tool here, we're seeing about a 16 RA micro-inch finish on this tool with just basic post-processing. So printing, milling, and then some basic hand finishing and a tooling sealer applied. And so we're seeing this, these vacuum integrity benefits and surface finish benefits of the 16 RA, for example, even before a primer or anything else goes on the tool. So I say typically most of our customers are looking for something around a 32 to 63 RA micro-inch, and that's easily achievable. And again, vacuum integral and as a fully durable finish. So next, we're going to talk about some of the kind of performance of these materials and kind of how we talk to our customers about these things, but also how we're validating these things. And I'll hand the ball to Zach here.
So because it's an extrusion, you get these anisotropic properties. This is in some ways very similar to traditional thermal set composites, but everything's kind of turned 90 degrees. So when possible, obviously we'll do our best to control the CTE, which is typically lowest in the X direction, which is the extrusion direction, and Z would be the stacking direction. So quite often we will try our best to say print it in the situation you see on the left, where X is dominated down the length. So it just really keeps the CTE down on the length of the tool. But sometimes that's not possible. So we also have the option to do a horizontally printed tool that's quite typically driven by geometry. But that would lead you, or would leave you with a Z direction that's running down the length of the tool. And then the low CTE kind of circulating as those loops go around. So as Greg mentioned, we have been doing long-term vacuum integrity tests as well as dimensional tests on our test tool. So after 250 autoclave cycles, we took the tool up to 180 C and 7 bar, and we shut off the vacuum. And what you see here is the raw autoclave data. I apologize, it's all in imperial units, but you can see at pressure, at temperature, the probe 1 dropped about 0.2 inches of mercury or 7 millibar, and probe 2 kind of fluctuated a little bit. We're just going to call that 0. So overall, great vacuum integrity at temperature and pressure. We also did a fiberglass leak check. It's more as a way to isolate that even with that 0.2 inches of mercury, that the tool itself in the field area is not losing vacuum integrity. So for those of you not familiar with the process, you take some thin fiberglass, like a 7781 style fiberglass, and we impregnated it with our own benzoxazine resin system. Typically in the industry, they're done with epoxy, but we chose our benzoxazine specifically because of the very high gel point of 163 C, where the benzoxazine starts to cross-link and thicken. So we wanted to have as broad of a window as possible, where you might see any air getting entrapped in the laminate. So again, for those not familiar, what that would look like is almost like a starburst of porosity coming through where a leak would be in the tool face. So as you can see, a very clean laminate, a very high gloss as well, but zero indications of any porosity in the laminate and just an excellent surface finish. Also looking at the dimensional stability. So we were laser scanning the tool periodically through the cycle testing. And what you see on the right-hand side is an overlay of the data after thermal cycling and then compared to the original scan data. So no deviations greater than 0.005 of an inch or 0.127 millimeters to the original scan data. So overall, just great dimensional stability, and really not seeing any failure in that mode either. Also looking at how the surface holds up. A common kind of misconception is the material toughness. You know, Greg kind of mentioned it, but The material itself is approaching, about the hardness of aluminum. And as many of you know, aluminum's been used for decades in the composite industry. So we've seen really excellent laminates coming off with all of our own resin systems, our benzoxazine, our Toolmaster epoxy, our cyanate epoxy, and our LTC, low temp cure epoxy systems. Just a couple examples there on the right of the laminates that are coming off, and you can see just the really high gloss. But we are also testing all of the production resin systems, frankly, any ones we can get our hands on. But we've had really good results with BMIs, epoxies, cyanate esters, both in autoclave and out of autoclave applications. And if we haven't tested your production resin system, send us some material and we're happy to give it a go and provide some feedback. Also looking at things visually. So this is the tool after 250 autoclave cycles. You can still see that it's got a really good surface finish there and it's holding up well, but no visible deteriorations or evidence of any kind of oxidation or surface damage. And also looking at things under the microscope. So about 1,000-time magnification here. So really no evidence of microcracking in that surface. The kind of the Achilles heel of traditional thermoset composites is that they will microcrack. And over time, those microcracks will ultimately lead to a loss in vacuum integrity or gross delaminations. Really not seeing any evidence of that whatsoever on the tool surface. As far as the accuracy capability of the molds, really what we are finding is that it's a limit of the machine, right? So as long as you have a machine that can cut, say, aluminum very accurately, you can also cut these materials very accurately. So we've seen some great results both in our in-house testing, but also with customers. And that would include holes as well, precision holes that can be installed in machining. But we've seen a lot of proven results with masters, layup molds, preformed tools, holding fixtures, trim fixtures, drill bars. You name it, there's definitely a fit for this technology. Another thing that many people hadn't thought of or looked at yet was how do you mount all the hardware that's traditionally included with tools for handling or just things like integrating plumbing and for vacuum mill fixtures and things like that. So we've in reality, most of the traditional approaches can actually be applied. And as you can see, just an example of a mill fixture there with some hoist rings, a vacuum manifold, and some integrated plumbing. But all of these things can be installed on these tools. Also looking at things, more holistically and what else is in contact with the tool, whether it's a sealant tape or, bagging films, those things. We've really kind of vetted all those out and, we have a complete catalog that we can provide you with that goes through and says, hey, with this kind of tooling, here's what we recommend. We've tried it. It works very well. Also looking at the thermal performance of tools. So just an example of a large fairing mold that we did and trying to just encourage heat flow around these tools. Overall, we haven't seen any, poor performance of the tools. They've all been well within spec, but that also includes integrating things like minimal phase sheet contacts. Those higher mass concentration areas create heat sinks and allowing for that proper airflow, whether it's a large windows, and integrating other, handling type features like fork tubes. All of those can get included at the design phase. Another kind of interesting thing that you could do with this technology that per se you could do with alternate technologies, but we'll also do things like contoured headers or having a header only touch the face sheet where it's needed and essentially grown to touch the face. But we've seen very significant improvements over, say, foams like epoxy or urethanes and stuff like that, just because you have this airflow.
So our goal here today was really just to kind of give you guys a little bit of background information and kind of show you that, you know, the information is there, at least from Airtech as a resin supplier and tooling producer, doing large scale tooling for the past year and a half here. We really try to put ourselves in our customers' shoes and say, you know, what are your worries? What are your concerns? And can we make sure we address them? And the answer is yes. You know, we have way more data than we can show you in 30 or 40 minutes of presentation. so of course we left some time today to make sure we can talk about some of these things with you as participants here, and make sure we maybe can address some of your specific questions, or as may require a much longer conversation. You know, we have our contact information on the screen for you guys to take down. And if you'd like to have a follow-up conversation with us to get into much more detail, we have a wealth of data of our materials in various applications that we've fully validated to many customer specifications, even at the OEM level. So we'd happily entertain your questions or comments today, but as well as beyond. Please make sure you reach out to us, and be happy to engage you and provide some information to show you how these materials can work in these applications in a production-ready scenario.
So thank you very much, Gregory. Phil, Zach, thanks for the presentation. We now have the possibility to answer some questions. And as mentioned in the beginning, you either can raise your hand in the reaction down at the bottom. There's the raising hand function, and then you can unmute yourself when we ask for your name, and then you can ask your question, or you can just type your question in the chat, and then I'm going to read that, and the guys are going to answer that. Feel free to use both. And otherwise, as already said, you have the contact details of the Airtech team, and they are more than happy to answer your questions. And maybe there are some question topics which are better discussed bi-directional and not in a bigger group like this. Just feel free to contact them at any time. Do we have some questions from the audience? Well, I think as it seems now, you obviously answered them already, or you were that detailed that there are currently no questions so far. I'd say we wait for another few seconds if there's some hand or some question typed. Otherwise, from my side, I want to thank you guys very much for your presentation and for your time. And I'd say goodbye here, and of course, I leave you the stage to say goodbye to the audience. And thanks again. Thank you very much.
Yes, thank you all. We appreciate your time today. And again, please feel free to reach out with any questions. Thank you.